The next way we can factor is by factoring quadratic like. So we're going to factor the polynomial like a quadratic, but we have to use appropriate exponents. So we know we can use a quadratic like approach if our exponents are to the fourth, to the second, and then a constant. So if you look at these examples here, right, we see 4, 2, and then nothing. So that means that this can be factored quadratic like. So what this means is we're going to just pretend for the first one that it is a quadratic. So if this were a quadratic, this would be x squared minus 3x minus 4. And if we were factoring this, we know that we have to come up with two numbers that would multiply to -4 and add to -3, which would be -4 and 1. So we could write this as x plus 1 and x minus 4. When you're factoring quadratic like, the only difference is that instead of x, we have to use x squared. So instead of x plus 1, x minus 4, we're going to have x squared plus 1 and x squared minus 4. If I were to FOIL this back, I get my original equation. So we're factoring it the same way, we're just using x squared instead of x. Since we have two quadratics here, we want to see if we can factor them further. X squared plus 1, both x squared and 1 are perfect squares, but we have a plus sign instead of a minus sign, so we can't factor this because it's not difference of squares. X squared minus 4, x squared and 4 are both perfect squares, and there's a minus sign in the middle, so we can factor that more. So we'll keep the x squared plus 1 as is, and we'll rewrite x squared minus 4 as x plus 2, x minus 2. And because this is just a factoring question, because there's no equal sign, we're just going to leave it like that. In number 2, we see that equal sign, so first thing we have to do is set it to 0. So we'll add 4 to both sides. So we have 2x to the 4th minus 9x squared plus 4 equals 0. We see that 4 to nothing, so we know we're going to be using quadratic like. So in this case, a is not 1. So we have to come up with two numbers that are going to multiply to a times c, which is 8, and add to b, which is -9. So we'll use -8 and -1. So just like we would before, we have to do the longer method. So we're going to bring down the 2x to the 4th and bring down the 4 and rewrite the -9x squared. Now instead of writing it as -8x and -1x, because they have to add to the x squared, we're going to write x squareds instead of x. So we have -8x squared minus 1x squared. This is still equal to 0. So we have these four terms, so we're going to group them. Taking out the GCF from the first grouping, which is 2x squared, and we're left with x squared minus 4. Second grouping here, GCF would be -1, so we have x squared minus 4. Take the two outside terms, put them together, so 2x squared minus 1 and x squared minus 4. We have two quadratics, so we're going to see if we can factor them. 2x squared minus 1, if I try to factor that, the x squared is a perfect square and the 1 is a perfect square, but the 2 that's in front of the x squared is not a perfect square, so I can't use difference of squares. So we're going to leave this as 2x squared minus 1. And then x squared minus 4, similar to the problem before, that is difference of squares, so we have x plus 2, x minus 2, set it to 0. So if I set each of these factors to 0, I'm going to get x equals positive 2. I'm going to get x equals -2. And then the last piece here, I'm going to take 2x squared minus 1 and set it to 0. So I'm going to add 1 to both sides, so 2x squared equals 1, divide by 2, so x squared is 1/2, and then take the square root. So when I take the square root, remember that we do get plus or minus, and I have the square root of 1/2. Now this is not fully simplified, so in order to fully simplify this, when we have a square root that's a fraction, what we can do is break it up into the square root of the numerator and the square root of the denominator. So the square root of 1 is just 1, and then we have square root of 2. In math, we don't like to have a radical in the denominator, so we want to get rid of it by rationalizing. So that means we're going to multiply the top and bottom by that radical. So square root 2 over square root 2. So we multiply 1 times square root 2, which is square root 2. And then we multiply square root 2 times square root 2, which is 2. So the original problem had a degree of 4, so we should have 4 answers. We have 1, 2 here, and then the plus or minus is another 2 answers. So that's a total of 4 answers. The last thing we're going to look at is sum and difference of cubes. So here are the formulas for them. You can remember them in terms of A's and B's, but we're going to kind of go through how we can remember the setup of them instead of the actual formulas. So you know you can use sum or difference of cubes if there's 2 terms and both terms are perfect cubes. It doesn't matter if the sign's plus or minus because you can use it for both. So if we look at number 1, again, we're just going to factor it. There's no equal sign. So what we want to do first is take the cubed root of each of these terms. So the cubed root of x cubed is going to be x, right? Because x times x is x cubed. The cubed root of 64 is going to be 4, because 4 times 4 times 4 is 64. So the first thing we do is we break this into the cube roots. If you're going to use the equations up here, because we have a plus, this one we would be using sum of cubes. Now every time that we see an A or B, instead of using x cubed and 64, we're never going to use those numbers again. So we're going to be using the x would be A and the 4 would be B. So you can just go ahead and plug them right into the formula. The way I like to think about this is just the placement of everything. So I know I have 2 parentheses, the first parenthesis and the second parenthesis. So in the first parenthesis, I like to kind of point. So it's going to be this and this. So I know I'm using the left and the right. So x and 4. And I'm going to go back and fill in the signs in a minute. So left and right, which is x and 4. We're going to square the left, which is x squared. Multiply the 2 together, so that's 4x, square the right. So we get 16. So it's this and this, left and right, square it, multiply it, square it. Once you have the numbers written out, we're going to use an acronym called SOAP, and that's going to stand for same, opposite, always positive. And this will help us figure out the signs, because if you notice from the 2 formulas that we have for the sum and difference of cubes, they're very similar. The only difference is that the signs are different. So we have a plus sign that we started off with. So our first sign is going to be the same, which is plus. The second sign is going to be opposite. So opposite plus is minus. And then the last sign is going to always be positive. So once we do that, we see that we do have a quadratic here. If we try to factor this quadratic, it's not going to be factorable. So anytime that we're using sum and difference of cubes, the quadratic that we get for the second piece will never be factorable. So once you kind of plug it into the formula, that's as factored as we can get. And again, there's no equal sign, so we just leave it like that. All right, for number 2, we do see an equal sign, so we have to set it to 0 first. So I'm going to minus 27. So we get 8x cubed minus 27 equals 0. Take the cubed root of each. So the cubed root of 8x cubed is going to be 2x cubed, right? 2x times 2x times 2x is 8x cubed. Then we have minus. Cubed root of 27 is 3, because 3 times 3 times 3 is 27. So again, we're going to set it up. We have the parenthesis and the other parenthesis. So we're going to do left and right, so 2x and 3. We're going to square the left. So when you square 2x, be careful because you might want to say 2x squared, but it's 2x times 2x. So that's going to be 4x squared. Then multiply the left and right together, so that's 6x. And then square the right, so 3 squared is 9. Now we're going to use SOAP, so same sign. We started with a minus, so same, opposite, always positive. So if we were just factoring, we could leave it like that, but we're going to solve. So we'll take the 2x minus 3, set it to 0. So 2x is equal to positive 3, divide by 2, so x is equal to 3/2. Now the second factor that we have here, this quadratic, we know it's not factorable. If you want to try to factor it, you can. It's not going to work. So when we can't factor something, we have to use the quadratic formula. So we're going to do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Extend that a little bit. So we get x equals negative 6 plus or minus the square root of 36 minus 144 over 8, which gives us negative 6 plus or minus the square root of negative 108 over 8. So once we get the square root here, we want to break it down before we do any type of like dividing or simplifying. So we know there's a negative in the square root. Every time that you do the quadratic formula with the sum and difference of cubes problem, you're going to get a negative in the radical. So we have to pull out an I for imaginary because of that negative in the radical. So we'll do that in a minute. And we're going to break down 108. So 108, you can look for perfect squares within 108, or just break it down by any numbers that multiply. So I'm going to say this is 9 and 12. 9 breaks into 3 and 3. 6 breaks into, 12 breaks into 4 and 3, and 4 breaks into 2 and 2. Once it breaks down, you can't use it again. So we can't use 108, 9, 12, or 4. We're going to look for pairs of the same number. So we have a pair of 3s and a pair of 2s. So when we go to write this out, negative 6 plus or minus, the pair of 3s is going to have a 3 come out. The pair of 2s is going to have a 2 come out. So since there's a 3 that comes out and a 2 that comes out, they're going to get multiplied together to give us a 6 on the outside. Because it was a negative, we're going to pull out the I. And then there's this 3 that's left over. That's going to go inside. And then we divide it by 8. Once we've broken down the square root, we're going to look to see if the numbers in front can be divided by the same number. So we look at the negative 6, the 6i, and the 8. Can they all be reduced by the same number? Yes, they can all be divided by 2. So we're going to get negative 3 plus or minus 3i root 3 over 4. And again, this problem should have 3 answers because the exponent was a 3. So we have 1 up here, the 3/2, and then this plus or minus answer is going to be our other 2 to give us a total of 3 solutions.